Okay, let's do this. This is week 3, algebra 2. So I'm going to go to week 3, scroll down, and there are going to be, it's going to be a video right there once I'm done recording this. And there we go. We're going to do getting ready for transformations of functions, modeling with functions. So that'll be really fun. Okay. Yeah, and it's all in the same thing. Just going to do quiz 1. Here we go. The table compares the daily average temperature in a park in degrees Celsius and the number of people who visited the park that day. Can the number of people who visited the park be represented as a function of the daily average temperature? Okay, well, if it can be represented as a function, then that means that each input goes to a unique output. They can go to the same output, but the input of 12 can go to 2 different places. So 12 is the input. These are the in. This is the out. 12 going to 10, then it has to go to 10. I can't see 12 down here and it's going somewhere else. So right here, I see 11 goes to 17. And then I see 11 again, but it's going to 17, so that's okay. So any other numbers? Okay, 16. I see that twice, but both times it's going to 27, so that's okay. And all the other numbers only appear once, so this is a yes. It works just fine. But if any one of those repeaters had been going to a different output, it would have been no. Pooja's plant began sprouting 2 days before Pooja bought it. She had it for 98 days until it died, and at its tallest, the plant was 30 centimeters tall. H of T models the height of Pooja's plant, T days after she bought it. All right, very good. So Pooja's got a plant. I'm just drawing a picture. You know, it was a certain height when she bought it. This is height, and this is time. And then it grew and grew. And then, I don't know, it died, but it didn't get smaller, I don't think. Maybe it did as it died. I don't know. But what is the domain? The domain is time. And the range is height. And both of those measurements can include decimals. Time, you can have 1.2 days, and so on and so on. It's not like people or books. Well, yeah, it's not like some things that can only be integers, no decimals. Was the appropriate domain? Well, we know the domain is time, and so 98 days. So I would say 98 is the maximum, -2 to 98. We could do that. We could do 0 to 100. I don't know. Let's see what it says. There you go. -2 to 98. Okay. I mean, there could be an argument that we could do 0 to 100. I think -2, 2 days before she bought it, and then 98 when it died. Okay, what's the domain of G? So this is a linear function. So let's just talk about restrictions on the domain for a brief second here. Let me type it out. Okay. Restrictions on the domain. You cannot divide by 0, and you cannot square root a negative in the real numbers. In algebra 2, you will learn about imaginary numbers, which can be square rooted even if they're negative, okay? But not in the real numbers, which is usually where we start, real numbers. Okay, so What does that look like? That looks like if there's a denominator like that, we can't have 0 in the denominator, so the domain would be all real numbers such that x is not equal to 0. Or maybe we have another one like this. So then the domain, if I put 0 here, I would end up with -2 on the bottom. 0 is actually fine. What number? Why am I putting a comma there? All real numbers. But this time x cannot be 2, because if I put 2 there, it would make 0 in the bottom. So that's the first one, where you can't have 0 in the denominator. The second one is the square roots. So let's say we had, the function is the square root of x minus 5. Well then, that expression has got to be greater than or equal to 0 in order for it to not be negative. It has to be greater than 0. And so if I solve this, I will end up knowing the values that will work. So any x value greater than 5 would work. So that would be the domain. The domain would be all x's greater than or equal to 5. So there's those sorts of things. But here, there's not a denominator. There's not a square root. So it's just going to be all real numbers. Okay, so the range, as I said, is the y coordinates. So we just look and just, for this one, just every y coordinate. So it's like, it's either this one or this one. So, so it's just 1, 5, -4, and 3. 1, 5, -4, and 3, and -3. Does the graph represent a function? So graphically, if it passes the vertical line test, I can run a vertical line through it, and the vertical line passes through the function at only one point, then the answer is yes. I trust you can substitute -7 in and get the result there. I'm going to move on. Okay. So now let's do quiz 2. That wasn't so bad. Oh, yeah. Sinusoidal. Select the interval when f of x is greater than 0. So f of x is the y value. So the interval when y is greater than 0, it's there. It's from here to here, because it's anywhere that the blue graph there is above the x-axis. That's when f of x or y is greater than 0. So -2 to -1. -2 to, nope, it's right down here. 1 to 2. 1 to 2. Yes, that works. 1 to 2 is right here, and that is inside the part that I circled. Select the interval when it's increasing. So that's a different question. Increasing means it's going up from left to right, like the slope is positive kind of thing, even though it might not be a slope, but it's going up. And then decreasing, it's going down the slope, negative slope. So increasing, let's color in the increase. Right there is an increase, right here is an increase. So those are the two increases actually. At other places, it's decreasing. So -4 to -3. -4 to -3 is in my increase. And then there's more, but you can figure that out. Mark all the relative maximum points. So there's two types of maximums. There are relative is a max in its general like neighborhood on the graph. If you look at the values around it, it's the highest, it would be the max. You can also have a relative min. Absolute maximum is the maximum of the graph. There is no point higher than that. Not all graphs have an absolute. This graph has an absolute maximum right there. But we want to mark the relative maximum. So absolute is also relative, you know. And so it's just the tops of the mountains. Tops of the mountains, that's all it is. Absolute, I just explained that. Relative, okay, so you can do that. Well, I'm feeling good about this. I hope you are too. Let's move on to quiz 3. This is not taking me the same amount of time as saying. Function g can be thought of as a translated shifted version of the absolute value of x. And I do see that. Make sure you know your basic functions. There's many basic functions like y equals x. Y equals x is like that. Y equals the absolute value of x. Y equals something like 2 to the x. Y equals x squared. Please write all these down as well. Y equals log of x, like that. Y equals the square root of x. Y equals x cubed. And so just be on the lookout in Algebra 2 for basic functions. Because when you know the shape of the function, there's more. But I'll just stop there. When you know the shape of the function, you can think of lots of different graphs as just a shifted version of that function. So this is the absolute value graph, and it's just shifted over 1, 2, 3. And you probably did this in Algebra 1 and maybe forgot because, you know, it's been a year. So this number inside shifts the graph to the left and right, and the sign is opposite for the left-right shift. So -3, you would think would go backwards 3, but it actually goes forwards. The one on the inside is opposite. If there was a number on the outside, that would be up 2. Like you'd think it'd be up 2 because it's +2, and it would be. This would be right 3. Now we don't need the up 2 in this case because it's not shifted up. That was just for my example. So there we go. You can see that would be up 3, that would be down 3, and this would be left 3. Okay, so now we have a quadratic, and we know the zeros are -7 or +7 and -7. So let me just also I know that it opens down. There we go. Because there's a negative out front. And we want to know where the vertex is going to be. There we go. The vertex is right in the middle of the 2 zeros. So the vertex would be at 0. But if I didn't know that, I could have added them together and divided by 2, and that's 0. It's the x coordinate of the vertex, and you can always add the zeros together and divide by 2 to get that. Then you substitute the x coordinate in, you'll get the y coordinate of the vertex. So that would be -7, 7, -1, 7. And so just doing some quick math there, it ends up just being 7. So that means that I have to go up 7. Still works out. My zeros are in the right spot. Now my vertex is in the right spot. Doesn't look right to me though, that would be up at 7. I feel like it's at 1. Oh, I'm wrong. Okay. The graph of y equals the absolute value of x is reflected over the x-axis and then scaled vertically. Okay, so the scaled vertically means there's a number out front. You know, if it was scaled horizontally, then there would be a number inside parentheses or inside the absolute value. But anyway, so there's a 7 out front, like here and here, not a 1/7. It's also reflected, so it should be negative. So it's that one. If it was reflected over the y-axis, there would be a negative inside. You know, life is calling. Okay, let's keep going. The zeros of the function, so that we did the 1 zeros, but those were pretty easy now. And these zeros, just make sure that you remember the zero product property, which is basically you can set this the expression equal to 0 and solve it to find the 0, which, you know, you may be able to do it in your head, but just in case, make sure you solve it out. You don't miss a sign or anything like that. So there, we set the first thing equal to 0, add 5 to both sides, divide by -4, and voila. Here, I would subtract 5 from both sides, and then divide both sides by -1, and you actually get +5. So the greater 0 is +5, and the lesser 0 is -5/4. Graph the function. Okay, so we did factored form. This is standard form. Standard form is ax² plus bx plus c. And so when we graph standard form, we want to first graph the vertex, which is x equals -b/2a. And then I like to use the a value or a table to get one other point, and then, or 2 other points if you're not working on the computer. So anyway, a is 1, b is 4, c is 1. You should remember that from algebra 1. And so we're going to do -4/2 times 1, which is -4/2, which is -2. And that's the x coordinate of the vertex. So you know it's -2 comma something. How do we figure out the y coordinate? We substitute into the function. So the function is x² plus 4 times x plus 1. So that's 4 minus 8 plus 1. -4 plus 1 is -3. So it's -2, -3. So we can put that -2, -3 right there. And since the a value is 1, that means I can go over 1, up 1, and I have the second point. If the a value was 2, I would go over 1, up 2 on either side. You know, it's kind of like the slope. So that's one thing. All right, this is a good one. So remember shifting. So this is left 4, up 3, and then that 4 out front means it. Well, let me show you what that means. So I'm going to go left 4, up 3, and then because there's a 4 on the outside, I'm going to go up 4. So over 1, up 4. So it works kind of like the quadratic. Okay. This one is in vertex form. So let's talk about vertex form. Y equals ax minus h squared plus k. But you can think of it as the shifting. And so it's shifted right 2. And then that -3/2. So, you know, using my thing over 1, you could go down 1.5, but it won't let us go down 1.5. So unfortunately, we have to substitute into a table. So I'm going to make a table, and my vertex I know is positive 2, 0. And I can't if I substitute 3 in, it's going to be a fraction. So let me try 4. I substitute 4 in for x. I think it's going to be just fine. That would be 2 squared, which is 4. So 4 times negative 3 halves is going to be negative 6. So that would make one of the points on the parabola 4, negative 6. So let's graph that. Got it. All right. Last one, quiz 4. Maybe a little tired, but hey, let's push through. It's the summer. You should not be in any other classes, so more time for math, right? Take a break if you need to, and then let's do quiz 4. Graph the equation. Okay, well, actually, I already did one like that, so I'm just gonna skip that. In case you don't remember, you're gonna plot the zeros, and then the vertex is in the middle of the zeros, and then substitute that x coordinate in to get the y coordinate. You can do it. The parabola y equals x squared is reflected over the x-axis and then scaled vertically. All right, so then it's negative 1, 6. That's going to do both of those. So it's like that. What are the zeros of the function? Okay. So this is in vertex form. The zeros would be easy to find in factored form, but they're not too hard to find in vertex form. So the zeros means that y equals 0. So we could substitute 0 in for f of t, because that represents y, and then we could just solve it. So solving this means we're going to add 9 to both sides. 9 equals t minus 5. And then we take the square root of both sides. Now, when you take the square root in the solving process, you have to put that plus or minus there. And then we separate it into 2 equations. And negative 3 and positive 3 equals t minus 5. And then we just finish it. So that's 2. And that would be 8. So 2 and 8. 2, 8. And then the vertex is really easy in vertex form. It's going to be 5, negative 9. Because it's the numbers that we see, just that the x value is the opposite of what you see in the function. The parabola y equals x squared is shifted up 7 and left 1. Okay, so I'm going to use vertex form. Is shifted left 1, so that's going to be x plus 1 squared, and then up 7 means plus 7. Last question. All right, which form the vertex? So okay, so we want vertex form. That's right there. And what is the vertex? Okay, I'll do it. 8, negative 8. All right, now you try quizzes 1, 2, 3, and 4, and post in the organizer.